Imagine walking onto an enterprise engineering floor and, realizing nobody's actually typing code.
Right. It's just completely silent.
Yeah, like the furious sound of mechanical keyboards, the syntax generation, the manual debugging, it's just gone. And that is exactly the reality we are staring down today. So welcome to the deep dive. We are thrilled you're here with us.
We really are.
Because whether you're an engineering lead prepping for a major architecture strategy meeting, or you're just intensely curious about where the tech landscape is shifting this week, we have a really dense, fascinating stack of sources to unpack for you.
We do. We're pulling from this massive multi-sector dispatch of technical news straight from the desk of Andrew Kagan. It's a weekly intelligence brief that covers, 8 key sectors from Azure and DevOps all the way down to security and M365.
But, raw industry news can sometimes feel a bit abstract.
Exactly. So to ground these high-level strategic shifts in actual engineering reality, we are pairing Kagan's dispatch with an incredibly detailed free CodeCamp masterclass on software testing by Bo KS.
Our mission today is straightforward. We are going to cut through the information overload and connect the dots on a massive industry shift. I mean, we are moving out of the era of human-written syntax and into a world where AI agents are building, deploying, and managing software.
Right. The agents are doing the heavy lifting now.
Yeah, and together we need to figure out how to scale, test, and secure that entirely new reality without, bringing the enterprise crashing down. And to start, we really have to talk about that provocative headline from our sources.
Oh, about the engineering floor.
Yes.
Yeah.
Your entire engineering floor just stopped coding. Like, the research finding that GitHub Copilot's effect on collaboration has literally stunned researchers.
It has, yeah. Because what we're seeing isn't just a marginal productivity boost. It's not like moving from a slow laptop to a fast one. It is a fundamental rewiring of the development workflow.
Wow.
Yeah, the role of the human is shifting rapidly from syntax generation to architectural orchestration.
Okay, let's unpack this. Because if the engineering floor stopped typing syntax, what exactly are they doing? I mean, are they just pointing at a blueprint and watching the house assemble itself?
In a way, yes, but the mechanics of, pointing at that blueprint are incredibly complex. The dispatch highlights a new reality called agentic platform engineering.
Okay.
Developers are now building and deploying full-stack applications using the GitHub Copilot CLI and tools like Azure MCP, which stands for Model Context Protocol.
Right, and let's pause on MCP for a second, because if these AI agents are so smart, why do they need a specific context protocol? Doesn't the AI just kind of know what to do based on the prompt?
That is a super common misconception, actually. A foundational AI model knows how to write code in a vacuum, sure, but it knows absolutely nothing about your company's proprietary backend. Yeah. Azure MCP standardizes how AI models securely read local enterprise data and connect to your internal APIs. It essentially gives the AI the keys and the map to your specific environment. So the human engineer isn't writing the JavaScript anymore. Instead, they are configuring the MCP. They're acting as like a senior director, managing the agent's workflow, setting the context boundaries, and just reviewing the architectural output.
That makes a lot of sense. The developer job hasn't disappeared, it's just zoomed out. But I kind of have to push back a little on the whole syntax is dead narrative.
Oh, why is that?
Because right alongside these agentic tools, the news dispatch notes the release of PowerShell 7.6 for long-term support and extensive March updates to VS Code. If AI agents are writing everything, why do we still care about a deterministic shell environment like PowerShell?
Well, because orchestration requires a rock-solid deterministic execution layer. An AI agent might write the logic, but that logic still has to be executed reliably across thousands of servers. PowerShell 7.6 provides that robust infrastructure. So the foundational tools aren't disappearing at all. They are adapting to support a much more automated, agent-driven volume of work. But if these AI agents are going to do all this heavy lifting, they obviously need immense resources. Which brings us to the hardware layer.
Here's where it gets really interesting, because there is a massive hardware conflict brewing in our sources right now. On one hand, we have Microsoft recently demonstrating that, quote, AI doesn't need GPUs.
Right, they're exploring alternative paths.
Exactly. They are actively signaling a shift in the economics of AI infrastructure. But simultaneously, we see NVIDIA's Jensen Huang launching NemoClaw to the OpenClaw community, which massively expands the GPU-based ecosystem. How do we square that? I mean, it looks like Microsoft and NVIDIA are fighting a proxy war over the future of compute.
It's a fascinating dynamic. It's really easy to view it as a binary hardware war, but we are actually seeing the diversification of the AI ecosystem rather than a strict battle.
Really? How so?
Well, Microsoft has a massive financial incentive to break the NVIDIA GPU monopoly, right? GPUs are incredibly expensive, they're power hungry, and heavily constrained by supply chains.
Yeah, that's true.
So Microsoft exploring non-GPU pathways is really about finding cost-effective, alternative scaling methods for inferencing, which is just the day-to-day running of the AI models.
Right, because if you want every single business user on Earth querying an AI agent 10 times an hour, you can't afford to route all of that through a massive cluster of high-end GPUs. I mean, the economics just completely break.
Exactly. Meanwhile, NVIDIA isn't just sitting still. By launching NumClaw, they aren't just selling chips. They are providing the open source software orchestration to lock developers deeply into their specific hardware ecosystem.
Ah, keeping them in the walled garden.
Precisely. NVIDIA is pushing the absolute boundaries of high-performance compute for training massive frontier models. Both realities exist simultaneously because the demands of AI are splitting into two tiers, the massive training clusters and the lightweight, pervasive inference engines.
That makes total sense.
Yeah. But if we connect this to the bigger picture, whether you are using a cluster of GPUs or alternative silicon, the compute hardware actually isn't the primary bottleneck for enterprise AI anymore.
Oh, I know this one. The bottleneck is what the agents are actually chewing on, the data.
Precisely. AI agents are only as intelligent as the data surface they can access. If an AI agent has to cross 10 different siloed databases, authenticate through 5 different legacy permission structures, and, translate 3 different data formats just to answer a basic supply chain question.
The whole system just grinds to a halt.
Exactly, the agent times out.
Which perfectly explains the massive focus on data unification in Kagan's dispatch. The highlights from FabCon and SequelCon 2026 are completely dominated by Microsoft OneLake.
Yeah, OneLake is the mechanical solution to that exact bottleneck. It acts as a single, unified, governable data fabric for the entire enterprise. You don't move the data to the AI anymore, you connect the AI directly to OneLake.
And it's not just where the data lives, right? It's the language the agents use to interface with it. Like, the sources mentioned Google's new Developer's Guide to AI Agent Protocols. There's this intense debate outlined right now on which programming language you should actually use when building with Claude Code.
Right.
But why does the programming language even matter if the agent is just translating everything under the hood anyway?
It matters immensely because of the concept of deterministic boundaries.
Okay, deterministic boundaries.
If you build an agentic workflow in a dynamically typed language, like Python for instance, it offers immense flexibility, sure, but it can also let an AI hallucinate unhandled exceptions that break the pipeline completely silently.
Oh, yikes.
Yeah. But if you use a statically typed language, like Rust or TypeScript, you force the AI to adhere to strict memory and type safety rules. The language literally acts as the first layer of physical guardrails for the agent.
And we desperately need those guardrails. Because if you scale this up, which is exactly what the piece on 5 production scaling challenges for agentic AI in 2026 talks about, you run into a terrifying math problem.
You really do.
If AI agents can generate code and deploy infrastructure 100 times faster than a human, they can also generate and deploy catastrophic bugs 100 times faster.
Which takes us right out of the infrastructure layer and straight into the free CodeCamp software testing masterclass by BoKS.
And moving into this section, I have to ask, what stands out to you, to the listener? Because for me, it was the visceral horror stories in this course. I mean, that $440 million lost in a 45-minute lunch break.
Oh, the Night Capital disaster. Yeah, it is the ultimate cautionary tale in software engineering, and BoKS uses it brilliantly to frame testing not just as a chore, but as a survival mechanism.
It's terrifying.
Yeah.
In 2012, Night Capital deployed a software update that had a dormant bug they failed to catch in testing. Their automated systems just started executing erratic trades on the market, and in 45 minutes, $440 million gone. It bankrupted the firm.
It's wild.
The masterclass also breaks down the Therac 25 radiation machine from the 1980s, where software bugs literally caused fatal radiation overdoses. And it examines the Boeing 737 MAX crashes, where inadequate testing of edge case scenarios was a critical factor. It completely reframes software testing for me. It's not just QA ticking a box. It is literal insurance for your code.
And the economic reality of that insurance is stark. The masterclass highlights that finding and fixing a bug in production, like when the code is live, costs anywhere from 10 to 100 times more than catching it during local development.
Right, because the damage is already done.
Exactly. You aren't just paying for the developer's time anymore. You are paying for emergency hot fixes, the loss of customer trust, data corruption, and potential legal liability.
So mechanically, how do we prevent our new AI agents from becoming the next Knight Capital? The course introduces the testing pyramid, popularized by Mike Cohn. I know we've all seen the diagram, but let's skip the geometry lesson. In a world where AI is generating millions of lines of code, why does the architectural strategy of this pyramid matter so much?
It really comes down to compute cost and fragility. At the very foundation of the pyramid, you have unit tests. These check highly isolated individual functions like verifying that a specific algorithm correctly calculates sales tax.
Oh, wait.
Because they don't rely on databases or network connections, they execute in milliseconds. You can run 10,000 of them every single time your AI agent hits save.
And then you move up the stack to integration tests, which verify that those isolated components actually talk to each other correctly. But I really want to focus on the very top of that pyramid, end-to-end, or E2E tests.
Yeah, E2E tests are the most crucial, but also the most dangerous if you overuse them. They simulate real user behavior. They literally spin up a headless browser, navigate to your web app, click the Add to Cart button, and verify the checkout process.
Yeah.
BoKS's masterclass goes deep into building these using Playwright, which is this powerful framework from Microsoft that tests across Chrome, Firefox, and Safari simultaneously.
But E2E tests are incredibly brittle, right? Because if an AI agent decides to optimize the front-end code and slightly changes, like the CSS structure or the rendering order of the DOM, an E2E test looking for a specific button ID will fail, even if the application is functioning perfectly for the human user.
Precisely. That is why the pyramid shape dictates you have very few E2E tests. They take minutes to run and they break easily. But here's the fascinating twist the masterclass introduces.
Oh, yeah.
After teaching the mechanics of Playwright, it introduces a tool called TestMU. It's an AI-powered testing framework that allows QA engineers to write complex E2E tests using plain English instead of code.
And this is where my brain starts to melt a little bit. On one hand, we have developers using AI to write the application code. And on the other hand, we have QA engineers using AI to write the tests to check the AI-generated code. It is literally machines checking machines, with humans just kind of orchestrating the prompts.
Yeah, that's exactly what's happening.
What happens if the coding agent and the testing agent both hallucinate the exact same logic error? Are we just building infinitely faster race cars without bothering to upgrade the seatbelts?
Well, what's fascinating here is that exact vulnerability is why we have to pivot to the security and compliance section of Andrew Kagan's dispatch. If the AI is writing the code and testing the code, the immediate vulnerability becomes the environment itself.
Right.
How do you ensure these autonomous agents aren't quietly pulling in compromised third-party libraries or exfiltrating data? We're seeing a massive industry shift from reactive security to proactive observability.
Observability. That's a word that gets thrown around a lot. I always think of it like the difference between a smoke alarm and an MRI machine.
Oh, I love that.
A smoke alarm, which is reactive security, only goes off when the house is already on fire. And MRI observability looks at the internal state of the system to spot the tumor before it ever causes a symptom.
That is a perfect mechanical analogy. In a traditional deterministic system, a security alarm works fine. If someone tries to access a restricted database, you just block them.
Right.
But with AI systems generating novel SQL queries and making autonomous decisions, a traditional alarm doesn't know if a weird query is a brilliant business insight or a sophisticated data breach. Observability means having such deep visibility into the agent's reasoning, its memory state, and its data access patterns that you can detect anomalous behavior proactively.
Which ties perfectly into the sources detailing frameworks for guardrails for generative AI, which secure developer workflows at the point of generation, not just a deployment.
Exactly.
Kagan's dispatch also highlights data security investigations in Microsoft Purview, specifically pointing out the extension of attack disruption using third-party signals. This feels incredibly important. It means they aren't just looking at Microsoft's internal telemetry anymore.
Because modern enterprises don't exist in a vacuum, you know? You might use Azure for your cloud, but you have HR software, supply chain APIs, and third-party developer tools all running inside that environment. If you are only monitoring Microsoft's walls, you are completely blind to a vendor's API getting hijacked from inside the house.
So third-party signals act as internal security cameras, not just perimeter alarms. By integrating those signals, The security fabric can spot an anomaly in a partner application and autonomously sever the connection before the compromised agent reaches your OneLake data.
Exactly. And the dispatch makes it clear this isn't just theoretical. We are talking about navigating ITAR compliance, which involves strict U.S. defense export controls within the Microsoft cloud.
Wow, that's heavy stuff.
Yeah, the fact that these AI workflows, observability pipelines, and security postures are being actively attempted for GCC, which is the government community cloud, along with Azure Commercial and Azure Government, proves this infrastructure isn't a toy. It is robust enough to handle the most highly classified, heavily regulated environments on the planet.
So what does this all mean? For the person who isn't writing PowerShell scripts or managing government community cloud deployments, we've talked about the DevOps engineers orchestrating the code, the massive data lakes, the shifting silicon economics, the testing pyramids, and the MRI-level observability. How does all of this actually reach the everyday business worker?
It reaches them through complete democratization. The final tier of our source stack focuses on the 2026 Release Wave 1 plans for Dynamics 365, the Power Platform, and Copilot Studio. All of that massive backend complexity we just discussed is being completely abstracted away into user-friendly interfaces.
Right. We see updates like the M365 Copilot app learning series for real-world workday scenarios, or Power BI's deep dive into modern visual defaults and customizing theme improvements.
Yeah, exactly.
At first glance, a Power BI visual default sounds like a really minor UI patch, but really, it is the very tip of the spear. That simple visual chart is the endpoint of a massive pipeline. The user is visualizing data that was queried by an AI agent, pulled from a unified OneLake, secured by proactive observability, and tested by plain English AI frameworks.
Precisely. The technical barrier to entry has completely vanished. The dispatch even highlights learning resources like AI Foundations for absolute beginners. The true strategic impact of this era is that knowledge is most valuable when it is applied to a business problem.
Right.
These platforms now allow non-developers, financial analysts, marketing directors, logistics managers to build and orchestrate the very AI agents that the DevOps teams are securing in the background.
It's a complete inversion of how software used to be built. We've taken quite a journey today. We started on the engineering floor, looking at how the physical act of typing syntax is being replaced by agentic platform engineering and context protocols. We navigated the complex realities of fueling these AI agents, the compute proxy war between Microsoft and NVIDIA, and the necessity of unified data fabrics like OneLake. We felt the sheer terror of what happens when testing fails with the Knight Capital disaster, and learned how tools like Playwright and TestMU provide that essential architectural insurance.
Crucial insurance.
Absolutely. We explored how security is evolving into MRI-level observability to keep these autonomous agents on the rails, and finally, how all of this raw power is being handed directly to the everyday business user through tools like Copilot Studio.
It really is a remarkable inflection point. We are watching the construction of an entirely new digital nervous system, one where the human role is elevated from manual labor to strategic governance.
Which leaves me with one final lingering thought that I want to pass on to you, our listener. We've talked entirely about humans directing these agents, but if AI agents can now build the software, test the software, and secure the software, what happens when two rival companies deploy autonomous agents that start interacting, negotiating, or competing with each other in the open market?
Oh, wow.
If your procurement AI starts directly negotiating with a vendor's pricing AI, are we no longer just building software for humans? Are we actually preparing for an entirely new economy of agent-to-agent software? Is the future of human work no longer about doing the task, but simply having good taste, managing risk, and knowing exactly what questions to ask?
That is the defining architectural question for the next decade.
It really is. Thank you so much for joining us on this deep dive into the mechanics of our new reality. Keep asking those tough questions, keep exploring the architecture, and we will see you next time.